Okay, for this video, I'm gonna go over how you would like graph a line. So if we have an equation of a line, how we would graph it, how we figure out what the slope of this line is, and then the general form for the equation of a line. So let's just take a simple function of one variable, and so here I have one. It's y is equal to 5x plus 2. And if we wanted to graph this, then, well, anytime you have any function that you have to try to graph, the simplest way to do it is to just plug in some values for x and see what the values for y are. So this will work for any kind of a function, even if it's more complicated. Just pick some values for x, plug them into the function, and figure out what the value of y must be. So, for instance, and then we'll make a little chart of them, and then we'll graph them. So we'll make our little chart here, and the simplest one is always just if you put 0 in for x, because then things reduce a lot. So if you put 0 in for x, you've got 5 times 0, that's 0 plus 2. So if you put 0 in for x, you get 2 for y. And then if you put 1 in for x, you get, well, 1 times 5 plus 2, there should be 7. And if you put in 2, you'll get 12. And then you could also put in minus 1, because it's possible, depending on the nature of the variables and specifically what you're looking at, it's possible you could have negative numbers. Sometimes you're going to rule that out. In a lot of economics, we're not going to worry about being over here in the negative areas, because we're talking about things like prices or quantities of goods where negative numbers don't make a lot of sense. But these are just x and y, so we can take a negative 1. And then if you had negative 1, you see the value of x would be negative 3. So we've got some numbers here, and then we can come up and try and graph them. So let's see, we got 0 here for x. And I'm going to try to graph them relatively carefully here. So here's 2 for y. Well, that's 2. And then if you have 1 here for x, well, 1, we're going to do 7. A point there, a point there. Minus 1 over here will have to be done at minus 3 for y. It gives us a point there. And then if you're careful, because you have to try to be careful here, 2 will give us 12 up here. And we can have some points here to graph. And then it's just a matter of any 2 points determine a line. So when you go to graph it, the line is going to go through these different points. And if this wasn't a line, you'd be putting numbers in here. You'd be getting, you could still go through the same approach to try to graph any function that you have here. So here we have. Okay. But try to be careful here in drawing it, because if we draw it correctly, we'll have a straight line. So let's see if we look at a couple of things here. First, let's consider the slope. The slope of this line, well, the slope is going to be the change in x, or the change in y divided by the change in x. And mathematicians use the Greek letter delta as a shorthand for change in. So this would be the change in y divided by the change in x. Another way of thinking is the rise over the run. So if you remember that one, you can always, that's an easy one to remember. I remember that from 8th grade. Rise over run is another way to remember how you calculate a slope. Okay, so we could take any 2 points here. So suppose we take the first 2 points I have here. And the change in y, well, let me go 7 minus 2. And the change in x is 1 minus 0. The slope would be 5 over 1, or 5. Now, that's interesting, because when we look at our equation here, we see that, like, oh, we had 5x in the equation. So it turns out here that the slope was right there. The slope was right here in our equation. It's the coefficient on x. And then when we plugged 0 in for x, we got a value of 2. And so the line was going through or hitting the what we call the x-axis or the y-axis here at 2. And if you look at our equation, we see that we've got a 2 right here. So that's we were picking up the what's called the y-intercept here. The 2 is the y-intercept. So we're getting that there. So that allows us now, if say we change the value of 2, we would be changing the y-intercept. So let's suppose we change the value of 2 there to let's make it 4. If we make that change that 2 to a 4, well, when we plug 0 in for x, we now get 4, not 2. And then when we come over here to at 1, at the value of 1, instead of getting 7, we get 9. And then 2, instead of getting 12, we get 14. We would have shifted the curve, this line here, up. Whoops. By exactly 2, by changing the value of the constant term here from 2 to 4. So that allows us to see what happens as we change the y-intercept of a line. And then if we change the coefficient on x, we're changing the slope. And if the coefficient here becomes a smaller number, then the line is going to become flatter. Because again, rise over run, change in y. If we have a smaller change in y for a given a change in x, that's going to be a flatter curve. And if we put a bigger number in there, then the line is going to become steeper. And so it would become even steeper than what we have drawn here. So that allows us to sort of see what happens as we change the slope or the y-intercept of the line. Now there's a general form in which we can write the equation of any line, and that's we can think of this as a slope-intercept form. Mx plus b. All right, so this is like the general form of the equation of a line. Every line can really essentially be written in this fashion, where m is the slope of the line, and then b is the y-intercept. So there we have it. That's a very general form. This is nice because now, if we ever want to, like, say, take a demand curve and we want to say it's going to be linear, we know it. We can think about it in like slope-intercept form and write it in this fashion here. And so we know how we can really sort of think of writing an equation for like any line, not just a very specific line with specific numbers in there. We know how that is. And then we, once you're familiar with this, then when you have just y on the left-hand side, y and only y, because you don't have any coefficient here in front of the y, or it's got a coefficient of 1. And then we've got it in slope-intercept form, and the coefficient on x is the slope, and then this other constant term, that is the y-intercept. And so this is a very general way you could write the equation of any line. Okay.